Okay, today in Algebra 2 we're on Lesson 1-5, Solving Inequalities. Our objective today is to solve and graph inequalities and to write and solve compound inequalities. And again, this is review from Algebra 1, and I've put some bell work here, number 70, 71, and 72 to help you get started. In this, it says evaluate each expression for x equal -4 and y equal 3. So x equal -4 and y equal 3. So if you will substitute x and y with those values and solve, we'll come back in about one. You've been working on it for a few minutes, so I'm going to give you about 1 more minute and then we'll come back. Yes. Yeah, I know it's frozen because I'm just recording here. I erased all that, so I'm trying to leave those up for you to see. And then for the video, that's what I was doing now. We're good. So you've got about 1 more minute. The timer's going, but you're not going to see the time. You'll like this lesson today. Got 15 more seconds. I'm going to go ahead and switch this over. Sorry, that's loud enough to scare you to death. Alright, so I'm going to take a collective answer. Take your whiteboards and write the answer for number 70. Nice and big, and just hold it up where I can see it. And it doesn't matter if the person next to you doesn't have the same thing. Just grab your whiteboard and write it nice and big for number 70, the first one. Hold it up. I'm going to start writing down the answers that I see in the class. So far I see this, and I see one of these, and I see this. Okay, so I see 3 things. Oh, here's 4 things. I see one of those. Okay, and what is that? Okay, very good. So most of you had -7. So if I just say let's go with majority, we would go with that. If we had more time, I would say if this was a true class assignment, but being bell work, I'm not going to take a lot more time. But I would have you discuss at your table, teach each other, decide who's right and who's wrong. So here's what we need to do. Let me just rewrite this and let's solve it. So it's x minus 2y plus 3. And it says solve for x equal -4. So everywhere there's an x, I'm going to replace it with -4. And everywhere there's a y, replace it with a 3. Okay, so there's my first step, is just replacing x and y with the appropriate values. Now I'm going to follow my PEMDAS rules. So parentheses, there's nothing inside parentheses to do. There's no exponents. I do have multiplication right here. -2 times 3 is -6. So that's done. And I'm just going to carry down the other things. And I'm going to take the parentheses off my -4 and carry down the +3, plus 3. Alright, now we're going to, if you're still following PEMDAS and you want to do your addition first, you would do these two. -6 plus 3 is -3. Then you're left with -4 minus 3, which is -7. Okay? If you did these together, I'm not going to complain. As long as you got down to -7, that's fine. Some people did -6 plus -4 is negative 10 plus 3 creates a negative 7. But either way you got it, as long as you got negative 7, that's correct. Now, when we do these things, and we do whiteboard work and wherever you had all this worked out, as I'm going through it, you should be looking to see if you have errors, or maybe writing down my solution so you could take it home if you didn't get, say if you were one that had one of these, negative 6, 5, or negative 5, you need to look back at your work and see where did I go wrong and figure that out. Okay? Any questions? All right. Quickly, let's do the next one. So 71, we had x, and negative y. Again, write your answer really big and hold it up. You are already ready to go. Okay, there's another. Okay, I got this. I got this. Okay, I think it's that one. Yeah. 2 points. I've got this one. All right, I see basically mostly this one that I put the check mark by. But we don't know if this is right or not, right? So it's going to be x plus x divided by y. So it's going to be negative 4 plus negative 4 divided by 3. Negative 4 divided by negative 4 plus 3. Is that correct? There's x plus x divided by y. Whoops. Totally got the signs wrong. It's plus x divided by y. There we go. So if you follow your PEMDAS rules, you're going to do these two first. Negative 4 divided by 3. And that's going to give us negative 4 divided by 3, or negative 4/3. And I'm going to carry down the negative 4 plus, and I'll just put that in parentheses. All right? So negative 4/3, let's go ahead and just simplify that to a mixed number. It's going to be negative 1 and 1/3, which is also 1.3. All right? Now let's go ahead and just carry down our negative 4 there. So now we have negative 4 minus negative 1, negative 4 plus negative 1.3. So that's going to be a negative 5.3. So that is your answer. The ones that got the 2.7, I think you added negative 4 and negative 4 first, then divided by 3. So is everybody good with that? Are there any questions? So if you didn't get that correct answer, make sure you rework it tonight and get it correct, because these little things are so important in algebra. Okay, the last one, I'm just going to work this out real quick, and I need you to look at your answers. So we have 3x minus 4y minus x. So x is negative 4 and y is 3. Notice that you've got a minus x here, so it's minus negative 4. So I put it in parentheses. And when I'm substituting, I most always, put those in parentheses. First of all, to make them stand out, to show that's my substitution, and secondly, to help contain those signs, so I don't mix those up. All right, so we're going to do multiplication all the way down. So 3 times negative 4 is negative 12. And now I've got negative 4 times 3. That's also a negative 12. And then I have negative times negative 4. Remember, if the number's missing, it's just 1. That's like negative 1 times negative 4, which is a positive 4. Now you're going to do your PEMDAS. So the most correct thing would be to add negative 12 to positive 4, which gives us a negative 8. Carry down the other negative 12, and then we have a negative 20. And that's our answer, negative 20. Hopefully everybody got that. This was I've been spending a lot of time on the bell work at the beginning of the year, because it's basically really simple things that are super easy to make a little sign error on. So I'm really testing your algebra chops and your ability to remember those signs and those rules. So that's why I'm going over them. But am I going to do that all year long? No. Bell work is usually 3 to 5 minutes, and most of the time I'll say 1 or 2 things about it, and then we'll move on. All right, so today we're going to talk about inequalities. What's an inequality? Well, you've got these new symbols that we're going to deal with. And this is nothing but review. So you've got a greater than, a less than, greater than or equal to, less than or equal to, and we also have this one, which is not equal. These are our inequality symbols. Okay, so how do we use these? Well, we've already talked about, I said these are alligator jaws, and he's always going to chomp on the bigger thing, the bigger number. So if I have an 8 and a 5, well, 8's bigger, so he's going to want to eat the 8. So how do you say that? Well, 8 is greater than 5. So if you forget which is which and you've got to say it, or you've got to work something out and you just really need to know, make an example like that. Take a couple of numbers and say, okay, these are the alligator jaws. Make him chomp on the bigger number, and then that's the greater or the less. You know, you've just got to make your own examples. How do we use these? Well, if I say that x is greater than 4, we're going to write x and the symbol greater than 4. So the jaws are chomping on the x because he's greater than. X is greater than 4. So how do you graph this? Well, we're going to graph these on number lines. So if I have an x is greater than 4, I'm going to have a number line. I always like to put the number close to the middle, and we're talking about 4. So let's add a couple more numbers just to get our bearings. So 5 would be this way, and 3 would be this way. Okay, so x is greater than 4. So it means we're going to start at 4. It's greater than 4. So 4 is that boundary point. It means this is where we start. We're going to start at 4. But he's not equal to 4. Because he's not equal to 4, we're just going to put an open circle on 4. And then to show that it's greater than 4, we're going to shade it to the right. So shade the line and shade the arrow to show this goes on to infinity, positive infinity. Okay, any questions about this? Okay, I don't want to see people do this, a dot and an arrow. That's not acceptable. I need to see you really color in these number lines. Now, do you have to color it so heavy that it's ripping through on the other side? No, just enough to show it starts here, whoops, starts here and it shades this way. All right, now what if this said x is greater than or equal to 4? There's that greater than or equal to. Well, when it's greater than or equal to, it means it's also equal to 4. Not just greater than 4, but it's also equal to. So we have to fill in the dot to show that 4 is also included. See, we shade everything that's included. So now we've got the greater than part, this shaded arrow, and the equal to, the filled in dot. Any questions on that? Okay. Same thing for less than. If I had x is less than 3, okay, 3 is that boundary point. I'm going to put a circle around it. Okay, what is it? Is it equal to 3? No, so it stays an open circle. But it's less than 3, so we're going to shade less than 3 to the left. All right? And that's how you do that. It goes on to the negative infinity. Any questions about that? These are our symbols that we're going to use, and this is how you use them. So this brings us to our first problem. It says, what inequality represents the sentence 5 fewer than a number is at least 12? 5 fewer than a number is at least 12. So let's dissect this. We've already done the 5 fewer than a number. But usually they were saying 5 fewer than a number x or a number t. But they don't tell us what number to use. When they don't, we just use x. So 5 fewer than a number is going to be x minus 5. Everybody agree there? Now here's the new part. Is at least 12. So we know we've got a 12 over here. What does is at least? Well, let's put the number line there. Let's draw a 12. That means 14 would be this way and 10 would be down there. At least 12. At the very least, it can be 12. So that means 12 is included. So color in your dot. If that's at least, it means the smallest it can be is 12. That means it's going to be greater than. So it's greater than or equal to 12. So x minus 5 is greater than or equal to 12. Any questions on that? Right? So you'll have some problems like that. One thing about inequalities, we can solve those just like we solved equations, except you've got these symbols that are involved. Now, one thing about these symbols, inequality symbols, if you're solving this and you multiply or divide each side by a negative number, you have to flip the sign. So, for example, if I had negative 3x equal 15, all right, so I'm going to solve this. And to solve it, it's a one-step equation. I'm going to have to divide each side by negative 3 to isolate that x, right? And then I've got to divide that side. So whoops, that should have been less than or equal to. Forgot, we're talking inequalities, the whole purpose of the lesson. Sorry. All right, so I've divided both sides by a negative number. Because I just divided both sides by a negative number, I have to flip the sign. Okay, now solve it. So we're left with x equals, and negative 3 goes into 15, negative 5 times. So your answer becomes x is greater than, can I get that go away? Sorry, there we go. X is greater than or equal to negative 5. So on a number line, it looks like this. Here's my negative 5. Negative 10 would be down here, and 0 would be out here. So this is my positives. These are my negatives, right? And my boundary point is negative 5. So now I'm going to look at my symbol. It's greater than or equal to. Because it's equal to, I'm going to fill in my circle. And it's greater than, so it's going to move to the right. So this is how you work these guys, okay? Any questions? So if you're solving and you have to multiply or divide each side by a negative number, you've got to flip the sign, all right? And this is Algebra 1 review. So you should have done this in Algebra 1 already. All right, so let's look at the next problem. What's the solution of negative 3 times the difference of 2x minus 5 plus 1 is greater than or equal to 4? So start by writing your equation. And I think I blew it up. Nope, I didn't. Let me blow it up real quick. All right, here we go. So we're going to look for our symbol. There's our symbol, greater than or equal to. So all the work we've got to do over here. Right, so let's get busy on this. Follow your PEMDAS, so we're going to distribute first. Negative 3 times 2x is negative 6x. And negative 3 times negative 5 is a positive 15. Then carry down the plus 1, greater than or equal to 4. Okay, now combine like terms. 15 plus 1 is 16. Carry down the negative 6x, greater than or equal to 4. Now we're going to start solving. So subtract 16 from each side. We're not multiplying or dividing. We're just adding a negative 16. So we don't have to flip the sign because we're only adding. It's only for multiply or divide. So this goes to 0 and this goes to negative 12. So we keep that sign. So now we're down to negative 6x is greater than or equal to negative 12. Now we've got to flip the sign because we're going to divide each side by negative 6. So the sign flips. These cancel out and I'm left with x, and those cancel out. And 12 divided by 6 is 2. X is less than or equal to 2. And to graph that on a number line, which most of these ask you to, right? So the boundary point is 2, so put a circle. Do we fill it in? Yes, we do, because it's also equal to, and it is less than, so it's going to go to the left, because that's our negative side. This is our positive side, okay? Any questions on that? Now, had this just been x is less than 2, and there was never the less than or equal to, it was just all worked with a less than, then you would just have a shell, that plain open circle there. Right? Okay. Any questions? You guys are doing good. Let's work one on the whiteboard. All right? It says, what is the solution of negative 2 times x plus 9 plus 5 is greater than or equal to 3? So work that on your whiteboard, and I'm going to give you 2 minutes. I'm going to pause the video now. Well, almost. There it goes. I'm going to pause the video. And they're easy. You can do them. Thank you, and that concludes our video.